Hello, I'm Matt, and today I'm going to show you how I transformed my Raspberry Pi's terminal from this to this, a fully fledged coding IDE for C++ projects, providing code highlighting, IntelliSense, auto-completion, debugging, and much more. By sharing my journey, I hope you'll learn how to transform any Linux terminal into a powerful development environment. So let's get into it. Firstly, I started by flashing my Raspberry Pi with a Linux distribution I wanted to try out, Manjaro. In fact, I went for the Manjaro XFCE build because I knew that this desktop environment was compatible with some of the software I wanted to use. More specifically, since I was streaming my journey, I needed to share my main computer's mouse and keyboard with my Raspberry Pi, so I needed a software called Barrier to work. And unfortunately, it does not work on Wayland for now, so I couldn't really get KDE or Gnome. And if you don't know, Barrier is essentially a client-server software that acts as a mouse and keyboard server. So for example, my main computer is going to be running the server, and my Raspberry Pi is going to connect to the server, and then my main computer can then share both my mouse and keyboard with my Raspberry Pi. And furthermore, because I also wanted to monitor the Pi's resource usage, like CPU and RAM, I also installed a widget called Conky, a lightweight system monitor widget for Linux. Setting it up wasn't difficult, it just took me some time to find a nice configuration online and remove the widgets I didn't want to use or see on the desktop. Now going over to Manjaro settings itself, finding the right place to change settings was also a pain in Manjaro XFCE. I feel like some of the important settings were all over the place. For example, I wanted to change the behavior of my Windows key, and I also wanted a few custom shortcuts. This wasn't as straightforward as it should have been because I had to look into the keyboard settings as well as Manjaro's settings manager to change each of these settings. Unfortunately, I could see the same thing happening with other settings as well. And in my opinion, the Manjaro team just needs to group settings that make sense together and consolidate the whole thing. But now going over to the terminal emulator itself, I really disliked Manjaro's default terminal emulator. For this reason, I installed Terminator, which is a terminal emulator that I am quite used to, as I've used before many times, and is very popular out there as well. And it lets you split screens, customize layouts, and so on and so forth. It's very easy to use. So I set Terminator as my default terminal emulator. Now going over to the system requirements themselves, in other words, the packages I needed to install, I knew that I needed software for compilation, debugging, and project configuration in general. So here are some of the software I had to install via Pacman. Compiler software such as GCC and Clang compilers, as well as their debugger counterparts such as GDB and LLDB. Git, so I can clone my GitHub repositories. CMake, so I can configure my C++ project. Python, for no good reason really. And finally, Vim and Neovim. And in fact, I started this whole experiment using Vim, but later on it was quite clear that I had to switch to nvim as some of the plugins I wanted to use didn't really work on Vim very well. So now let's move over to the Vim/Neovim requirements. To manage all the plugins that I would need to install, I chose Vundle, a very popular Vim plugin manager. The very first plugin I installed for Vim was uCompletely, a code autocompleter, IntelliSense, and definition finder. Essentially, this plugin works with ClangD that reads the compilation flags and provides the IntelliSense information to Vim so that you can find errors in real time, definitions to functions, and so on and so forth. The second plugin that I installed was Fuzzy Finder, or FZF. This is an extremely quick file finder and can search for content inside files. And in my opinion, it's worth having this plugin installed because you can use it to quickly open files on Vim or to find files that contain snippets of code you want to edit. And needless to say, it does integrate into Vim seamlessly. After installing these two plugins, I added some more maps that would match commands such as Ctrl+F8 to the snippet finder in FZF and F12 to the go-to definition from uCompletely. At this point, I was essentially just trying to copy my setup from VS Code and Visual Studio, so nothing interesting there. On the following day, I installed a new Vim theme called Kanagawa and a new plugin called Chadtree, a file explorer for Neovim written in Python, along with the icons that I needed. The Kanagawa theme gave my setup a professional look and feel, and the file explorer really made a difference in Neovim, as you kind of expect to have a file explorer in an IDE. Now, this is where the pain really started as I tried to get the debugging working on Vim. The best plugin I found online was called nvim, which uses the debugger adapter protocol that certain IDEs, such as VS Code, follow to allow you to debug programs from inside Vim. I was actually expecting this to work with GDB as I was building my project for debug with GCC's compilers, but unfortunately, it seemed that nvim works best with LLVM's LLDB, so I had to install all the requirements for that first. Apparently, I read online that you can debug all programs compiled with GCC with LLDB. So I did a quick test to see if this would actually work in practice. So I built my project with GCC and debugged it with LLDB, and everything worked fine, making me even more confident that this plugin would work in the end. Long story short, I found this nice article by a guy called Dave Lage that outlines how you can get LLDB hooked into nvim DAP, as well as his key mappings such as the F keys to set breakpoints, step over and continue. This actually saved me a lot of time, as I didn't really want to read through nvim's exhaustive documentation pages. And oh yeah, could I interest you on some tabs? I did install this Vim plugin that would show open files as tabs for a more VS look and feel, essentially, and so I know which file I've got open more clearly. After setting up nvim DAP with LLDB, I could finally set a breakpoint and run a debug executable, and to my surprise, the breakpoint actually did hit, and I could see the line highlighted inside Vim. However, I realized that this nvim DAP has no UI, and the only thing I could really do is set breakpoints and watch the flow of my program. There was no stack trace, no local variables, nor could I input LLDB commands in Vim to find out values of variables. And this is where I came across nvim DAP UI, yet another Vim plugin I installed that would get me closer to a fully fledged debugger. And as the name implies, nvim DAP UI adds a UI on top of nvim DAP. By default, it comes with the stack trace local variables window and some other stuff that I really didn't want, and basically just cluttered my already small working space in the terminal. For this reason, I had to learn how to customize the UI. Fortunately for me, the documentation of nvim DAP UI was actually quite easy to learn, and it all boiled down to changing some Lua code that sets up the UI elements, as they call it. So all I did was to remove the watch buffer and another buffer that really seemed to be empty and I didn't really know what I was doing. After all of this and setting up even more numerous nvim key maps, I could finally edit my C++ project on my Raspberry Pi 4 inside the terminal. And what's most interesting is that whenever I was coding in C++ with IntelliSense, code completion and all of that, the CPU load on the Raspberry Pi seemed to be around 20 to 40%, which is really good when you compare to having a proper IDE such as VS Code installed, and I guarantee your Pi would stutter constantly. And that is it. I hope you've enjoyed this video, and I'll provide my nvim config files in the description in case you want to try this yourself. I've personally learned a lot about how nvim works, a lot about how other IDEs deal with debugging through the Debugger adapter protocol, and a bit of Lua as well, as everything seems to require Lua to configure in Neovim. And in case you're not yet subscribed, make sure to hit the subscribe button and turn on notifications for more videos like this one. Bye bye.